Welcome to Maths Classes 9th CBSE by GK Pillai. This is my second video on the chapter The Use of Coordinates of Class 9. As I have mentioned in the first video, coordinate geometry is in Class 10th at present. Sums related to only one formula is there in your present syllabus of Class 9th. I have already discussed clearly, along with examples, the basics of the chapter. In this video, I will be discussing the answers to textbook questions. Since the chapter was in class 10th, there are many board examination questions available. These questions may be asked in your school exams. You will find many of these questions as practice questions in my next video. Watch my videos till the end and subscribe to my channel. You can offer your comments in the comment section of my video, which will help improve my videos. Basics of the chapter I have already discussed in my first video. Still, I feel like discussing very briefly some of them. The two-dimensional coordinate system uses two lines at right angles to each other to mark points in the two-dimensional space or 2D space. This is known as the 2D space or two-dimensional space or coordinate plane. The horizontal line is called the x-axis and the vertical line is called the y-axis. These are called coordinate axes. This is the x-axis and this is the y-axis. The points are marked in the coordinate plane as x1, y1, x2, y2, etc. And many other things you will learn a bit later. These three things are very important as far as the coordinate plane is concerned. If you consider the point pxy, px comma y in the coordinate plane, for example this, x is the perpendicular distance of p from the y-axis and y is the perpendicular distance of p from the x-axis. You have got 2 points x and y. X is the perpendicular distance from the y-axis, that is 2 units. And y is the perpendicular distance from the x-axis, that is 3 units. The point of intersection of the x-axis and the y-axis is called the origin here, that is 0, 0. The coordinates of a point on the x-axis are of the form x, 0. If you consider this point, this will be 3, 0. And any point on the y-axis will be of the form 0, y. If you are considering this point, it will be 0, minus 3. As I mentioned in the beginning, you will be using only one formula for doing sums in this chapter. That is the distance formula. Distance formula we will be using for finding the distance between any two points in the coordinate plane. Suppose the points are p, x1, y1 and x2, y2. Then the distance between these 2 points will be pq equal to under root x2 minus x1 whole squared plus y2 minus y1 whole squared. Another thing, if you want to find the distance of a point from the origin, this distance, then we will be using under root x squared plus y squared. So OR will be under root x squared plus y squared. One more thing let me tell you. Here the formula is x2 minus x1 whole squared and y2 minus y1 whole squared. Instead of this, even if you use x1 minus x2 whole squared and y1 minus y2 whole squared, then also your answer will be right. The reason is here there is a square. That is the reason we can use, instead of x2 minus x1, we can use x1 minus x2, and instead of y2 minus y1, even if you use y1 minus y2, then also your answer will be right. Now let me start discussing the answers to the questions in the textbook. Limited questions where the values are of higher level, I could not mark it on the graph sheet, such questions have been left out. Otherwise, maximum questions, most of the questions I'll be discussing in this video. Here, there is a figure on page number 5 that shows Ryan's room with points O, A, B, C marking its corners. The x and y axes are marked in the figure. Point O is the origin. Based on the figure, answer the following questions. I am just writing the answer. You can refer to the diagram in the textbook and you can understand the answer. If D1R1 represents the door to Ryan's room, how far is the door from the left wall? That is the y-axis of the room. How far is the door from the x-axis? Answer is 11.5 units away from the y-axis and the door is on the x-axis. What are the coordinates of D1? Plus 8, 0. If R1 is the point 11.5, 0, how wide is the door? 3.5 units. If B1 0, 1.5 and B2 0, 4 represent the ends of the bathroom door, is the bathroom door narrower or wider than the room door? Bathroom door is narrower, 2.5 units. You will find these questions on page 7 of your textbook under Think and Reflect category. What is the x coordinate of a point on the y-axis? Any point on the y-axis is of the form 0, y. So x coordinate will be 0. Is there a similar generalization for a point on the x-axis? Yes, the y coordinate will be 0 in that case. Does the point q y, x ever coincide with point p x, y? Justify your answer. If x equal to y, that is, these 2 points are, for example, 3, 3, and this also will be 3, 3 only, then the 2 points may coincide, will be coinciding. Here, if x is not equal to y, then x, y is not equal to y, x, and x, y is equal to y, x if and only if x equal to y. Just like I discussed here. Is this claim true? Yes, it is true. This question is from exercise 1.2 of your textbook. On a graph sheet, mark the x-axis and y-axis and the origin marked. Mark points on the x-axis and y-axis, whatever is given. Now answer the following questions. These points are marked. This is what is given. I have not given here, but that's what they are saying. Place Ryan's rectangular study table with 3 of its feet at the points 8, 9, 11, 9 and 11, 7. I have marked. The first one is 8, 9, next is 11, 9 and 11, 7. What will be the fourth foot of the table be? 8, 7 here. Why it has to be? This is going to be a rectangle. And it goes like this. If this is 8, 9, this also should be 11, 9. That is the y coordinate. Now since it is a rectangle, here this has to be 11, 7. The same 11 should come down. So here what will happen? 8 will come down from here and 7 will come from here. So this coordinate will be 8, 7. What is the width of the table? The length also. Width of the table will be 2 units. And the length of the table will be 11 minus 8, 3 units. Another one. Look at Ryan's bathroom. What are the coordinates of the 4 corners O, F, R and P of the bathroom? These are 0, 0, F 0, 9, R minus 6, 9 and P minus 6, 0. What is the shape of the showering area SHWR in Ryan's bathroom? Write the coordinates of the four corners. See, if this is the bathroom, what are the four corners? S minus 6 plus 6, H minus 3 comma 6, W minus 2 comma 9, and R minus 6 comma 9. These points are marked according to this one only. Another question from your textbook. Triangle ADM is an acute angled triangle in the first quadrant. You can see this. How do we find the lengths of the sides AD, DM and MA? All the three sides of the triangle. These questions are under Think and Reflect on page number 9. For the first one, the answer will be using the distance formula. Once you are given the three coordinates, three vertices, coordinates of the three vertices, using the distance formula, you can find the distance. You can find the distance, length of the sides AD, DM and MA using distance formula. Now, think and reflect on page number 9. In moving from A3, 4 to D7, 1, what distance have been covered along the x-axis? If you draw a perpendicular line like this and join here, this will be the distance to be covered on the x-axis. So it is 3 to 7. That will be 4 units. And what about the distance on the y-axis? This is the distance. That will be 1, 2 and 3. 3 units. Can these distances help you find the distance AD? AD can be found by using Pythagoras theorem. This one. If this is the 3 units and this is the 4 units, using Pythagoras theorem, you can definitely find this distance to be 5 units. Another one. From here I am starting the end of chapter exercise questions. The first one is the basic one. What are the x coordinate and y coordinate of the point of intersection of the two axes 0, 0? Next one. Point W has x coordinate equal to -5 here. Can you predict the coordinates of point H here as well as here? It can be anywhere. Can you predict the coordinates of the point H which is on the same line through W, the same line, parallel to y-axis? So the line through the point W, we have to mark it in such a way that this will be parallel to the y-axis. So you can guess one thing, any point on this line will have the x coordinate -5 only. Depending upon the place where you are marking, you keep x-axis to be -5, x coordinate to be -5, and the next one. If the point is here -5, 0, if it is somewhere here, it will be -5, -2. Which quadrants can H lie in? It has to be in this quadrant as well as this one. That is the second and third quadrant. This is the first and the fourth quadrants. And also, this can be on the x-axis also. The point can be on the x-axis also and these two quadrants. Here you can see this point. Here, the third question. Consider the points R3, 0, A0, -2, M -5, -2, P -5, 2. If they are joined in the same order, predict two sides of ramp that are perpendicular to each other. You can see these two sides, MA or AM. This is perpendicular to PM, the first one. One side of ramp that is parallel to one of the axes. You can see this one, AM. AM is parallel to x-axis. two points that are mirror images of each other on one axis. Which axis will this be? Answer: M and P. These 2 points are mirror images. The distance between this point and this point is 2 units. Here also it is 2. So these are the mirror images. Now plot the points and verify your predictions. Now the next one. Plot the point z 5, -6 on the Cartesian plane. Coordinate plane or Cartesian plane you can say. Construct a right-angled triangle IZN and find the lengths of the 3 sides. I am drawing a right triangle like this. So these 2 lines should be perpendicular. This angle should be 90 degrees. Now what you can see? You can count this distance 1, 2 and 3. Here 1, 2, 3 and 4. Just like another triangle which I have shown you in the previous page. Now this is a right triangle with sides 3 units and 4 sides. Naturally, applying Pythagoras theorem, you can find IN also, that will be 5 units. Question number 5. What would a system of coordinates be like if we did not have negative numbers? Would this system allow us to locate all the points on a 2D plane? Points will be marked in the first quadrant only. If all the points are positive only, then it will be marked in the first quadrant. Negative coordinates cannot be marked in the 2D plane in that particular case. This is another important question. Are the points M, in the textbook it is marked star, may not be supposed to be asked in the school exam, but this is an easy sum, it may be asked in the exams. Are the points M -3, -4, 0, 0 and G6, 8 on the same straight line? Suggest a method to check this without plotting and joining the points. The points are given -3, -4, 0, 0 and 6, 8. They lie in a straight line when you mark it on a coordinate plane. Now by using distance formula, what we do, I have not done it here, but you can do and check. You find AM, you find AG, then you find GM. Sum of AM and AG should be equal to the value of MG. By using distance formula, we find distances MA, AG and MG. MA plus AG is equal to MG means the 3 points lie on the same straight line or the points are collinear. This is question number 7 of your end exercise, the last exercise. Check if the points R -5, -1, B -2, -5 and C 4, -12 are on the same straight line. Now plot both sets of points and check your answers. There is a difference between the previous sum and this one. In this case, we will find the distance using the distance formula. Then we will be plotting on the graph sheet. The distance formula x2 - x1 whole square plus y2 - y1 whole square. Now you can see one thing. I'll just show you this one. -2 - -5 whole squared plus -5 - -1 whole squared. When expanded and simplified, you will get under root 25. That will be 5. The next one, BC, you will find BC using the distance formula, and also RC, the whole distance of RC you will find. Now let us see. RB plus BC, when you add these two, you are getting 5 plus 9.21, that is 14.21. Now RC also we got 14.21 only. Hence the points lie on the straight line and we have marked it on the graph sheet. This is question number 8 of your textbook. Using the origin as one vertex, plot the vertices of first one, a right-angled isosceles triangle. This is the isosceles triangle I have marked. This angle will be naturally 90 degrees. Isosceles means two sides should be equal. Here I have taken 3 units, 1, 2 and 3. So here also it should be 3, 1, 2 and 3. So this is a right isosceles triangle. Here the vertex is 3, 0 and here it is 0, 3. This is the origin 0, 0. An isosceles triangle with one vertex in the quadrant 3 and the other one in quadrant 4. See, I have kept it here. This one is -3, -4. And this is 3, -4. So naturally, this is an isosceles triangle because from the point 0, -1, the same distance. This distance is the same as this one. So naturally, this will be an isosceles triangle only. And these 2 points, as required, these 2 points are in quadrant 3 and quadrant 4. Question number 9. The following are the coordinates of points S, M and T. State whether M is the midpoint of segment ST. Justify your answer. From whatever we have marked, from there only we have to say whether the points are in the middle. I have taken here S -3, 0, T 3, 0 and this is 0, 0. From here 3 units here and from here another 3 units here. So naturally M will be the midpoint of this line segment. I am repeating, -3, 0 is here, 3, 0 is here, and naturally 0, 0 will be the midpoint of this. 3 units here and 3 units here. Another one, 2, 3, 3, 4, 4, 5. You can see one thing, this straight line goes as the diagonal of one box only. It is the same thing here. So naturally, M3, 4 will be the midpoint of the line segment joining 2, 3 and 4, 5. The next one, plot the points A2, 1, B -1, 2, C -2, -1 and D 1, -2 in the coordinate plane. Is ABCD a square? Can you explain why? What is the area of this square? Here the coordinates are marked like this. See, 2, 1, -1, 2, -2, -1 and 1, -2. The appearance after marking the points, when the lines are joined, the appearance itself gives the form of a square. Just to find the area now, we will use the distance formula to find one of the sides, AB, under root x2 minus x1 whole square plus y2 minus y1 whole square. So 2 minus -1 whole squared plus 1 minus 2 whole squared. When simplified, you will get under root 10 as the side AB. Area of the square will be side into side, under root 10 into root 10. 10 square units is the area of this square. That is the end of my present video. If you have liked the video, please click the like button and also don't forget to subscribe to my channel.